the work that I'm presenting here is sort of aimed more at something called the World Data System, which is an SWE initiative, International Council for Scientific Unions. And my participation there is part funded by NRF. So the work that I do here is for me like the beer at the end of the day. So I have them to thank for the little bit of interest that they bring into work. The World Data System, I urge you to maybe go and have a look at the website. SWE has recently reinitiated or rejuvenated their effort to build a network of interlinked data centers that are distinguished by the fact that it contains hard, quality assured scientific data. So that's really the distinction between the WDS accredited data centers in the world and maybe any old data center that one might find elsewhere. So go and have a look there. The membership is growing, and it's currently, I think, at around about 35 or so approved members in the World Data System. And it's really the heavyweights of the world like NOAA and NASA and so on are all part of this family. Okay, so what are we trying to achieve here? We're defining 4 positions that I'm briefly going to talk through that has huge implications to my mind on how we're going to work with network-based information about the scientific endeavor of the world into the future. And that's why I think it's important for how we're going to work with communities of practice too, because it really tries to address the problem of maintaining ever-growing and ever more complex associations between the things that are involved in our scientific output every day. So there's 4 things that we call positions that I'm quickly going to talk through. The triple X here at the bottom, someone pointed out some time ago that it's an unfortunate choice on my part because it has all kinds of other connotations. But that's really what we're seeing as a to-be-formed organization, probably an international organization, that has to look after something that we call a reference model for scalable knowledge networks. So what we're trying to do is to say, if we are successful and we achieve our ambitious goals, that we will end up with essentially a defining architecture for how we are going to work with scientific knowledge into the future. So it's quite an ambitious statement. And underlying this, there is imagined to be a massive and open and liberalized metadata resource that can be mined for information and knowledge. What's happening at the moment, and I'll explain in a little bit more detail when we get to it, is that metadata as we know it is very structured and one-dimensional and unidirectional to a large extent. Whereas the way in which we work is with a loose and ever-changing array of relationships between people, institutions, projects, the data, the reports that they produce, their collaborations, and so on. So this effort is aimed at saying, what do we need to change underlying all of this to accommodate a more liberalized set of metadata to be used? So the 4 positions deal with mandates, with complexity, with scalability, and with standards. And I'm briefly going to talk about each of them. First of all, we need more metadata about what we do in initiatives and in networks, because it's our contention or our idea that there's quite a lot of duplication and let's say misappropriation of funding going into this enormous effort to establish infrastructure for science. So if we have the means of clearly defining what a network or initiative or project is setting out to do and where it fits into relation to other similar initiatives, then we can start distinguishing between these things. And a way to maybe look at it is these are only 5 dimensions, that there are many more. But if we can start defining what these initiatives intend to investigate or do in terms of time, space, the topics that they're covering, maybe how they're structured, their agility and so on, then we can start seeing where there's overlaps and gaps between the different initiatives. And I've just trivially here listed a few, like Google, which covers everything, all 5 dimensions to the 101st%, and things like the World Data System and Geo and so on. So the first thing that we're trying to achieve by having better and more liberalized metadata is to actually understand and characterize an initiative or a project or a new network and compare it to other existing networks so that we can make some kind of distinction between them. So there's a whole lot of things to be done, but I think the main thing to take from this is that we're going to have even more metadata, not describing the data, but describing initiatives and projects and institutions and how they work. The second thing to think about is that the internet is very, very large already and growing. If we're talking about the physical internet, it's like a fairly one-dimensional tree that branches out from these sort of root IP addresses to the furthest leaves that are available in this tree. But what really makes it work is the hypertext protocol, the World Wide Web, which establishes all kinds of additional links and jumps between these physical endpoints, and that's what we click on when we're working in the web. Furthermore, there are billions of these pages, but included into each of them, there is even more information of a relational nature, because it talks about people and places and projects and institutions and whatever, and it has implied relationships between them. I'm an employee of SAEON, and Heidi is a collaborator of Derek, and so on and so on. All of that information adds to this massive complexity that's available with all the possible relationships that exist in the web. So one of the other things that needs to happen is that we must reduce this complexity to make it manageable and so that we can get some productive use from it. So if we try and think about it from a different perspective, then we're saying here we've got typical science portals like SAEOS as an example, and in our opinion it has a low linkedness. It's very hierarchical and one-dimensional in how it presents the stuff that's available there. So the chances that you will find something there is actually quite low, but if you find something, the chances that it will be useful to you is very high, because it's focused and very narrow in its approach. On the other hand, there's this high linkedness situation like you have with the typical search engine on Yahoo or Google, where there's a very high probability that you will find something, but there's a very low probability that it will be of immediate use to you, that the first thing that you're going to find is actually what you're looking for. So by managing the complexity of this linkedness, the idea is that we can find some optimum, some maximum utility here in the middle, where the linkedness is just so that we gain let's say, maximum benefit from our effort that we have in searching for things. So that's more or less how we think this might work. We call that the sweet spot. So just to explain the complexity a bit more, if we imagine that everything is connected to everything, then the number of relationships between things grows sort of more or less the square of the number of things that we've got. So if we've got 3 things, then there's 3 possible relationships, and if we've got 6 things, then there are 15 potential relationships. The complexity grows. However, we can do a whole number of things, and librarians have been doing this for, I don't know, I suppose hundreds of years, and that is to categorize things. And what they're actually doing is they're putting things into stratifications so that the number of potential connections reduce. So you can see the effect of that, of taking 6 things and putting them into 2 groups with only 1 relationship between them. Complexity is now 7 instead of 15, it's more or less halved. But it's also worth noting that if we increase the number of levels, then the utility decreases. So at some point, if you think about it, instead of 100 unclassified documents, we have 100 files, each with 1 document in them, so we're back to square one. So there's also an optimum with a level of stratification or the depth of how we classify things that we need to think about. If we start applying this to metadata, which is the practical side of things, then what I've done is I've taken SAEON's metadata collection, which is around about 1,000 or so metadata records, and our prototype World Data Center for Biodiversity and Human Health, which has around about 10,000 metadata references. And I've expanded that by making additional connections based on the inferred relationships, such as who collaborates with whom, and who does research in what field, and so on and so forth. And you can see how the number of relationships grow in comparison to the number of entities that we have, and what the contributions of the different relationships are to that total number of relationships that I have eventually when I expand the metadata to account for all the relationships that I want. So that's what we're going to end up with, is a metadatabase that's expanded to include all of the inferred relationships as well. So thinking about a tree again, we're putting sort of connections in between the leaves and branches of this tree to make it truly connected and navigable as a network. Now this has implications because we now have a very much larger metadata collection, but we can also do a whole lot more with it. Not only that, and I'll come to that in a few minutes, we're not only going to add metadata from traditional sources into this expanded metadata base. There's a whole bunch of other things that we want to add into it. So the kinds of things that we can start doing now is build these networks, and you can't see it very well, but we can now start inferring relationships between people, between institutions, and so on, by just mining that metadata and presenting it in very different ways than we would traditionally have done. You've seen that while I recorded this movie, you were talking in the background. Someone was talking in the background. But anyway, so that's where we're aiming with this knowledge network of expanded metadata that I'm talking about.